Okay, for the agenda, and we will be seeing human interaction and a demo of how this human task is working. So this diagram is another way of representing the core engine. This runtime is the core engine, and here I have highlighted the process engine alone. There is this rule engine as well, but for this particular thing, that's not needed. So this is the whole runtime. We have the main process engine. This is a Jbpm engine, which is capable of managing the whole life cycle of the process. So basically here we are going to look at the human interaction. So process engine requires the help of this human task component. This human task component is a service enabled component. It's an SOA component. It's basically a exposed service. The name of the service is task service. So that's the human task component, which is able to manage the whole life cycle of workflows. And to manage any human interaction, process engine needs to delegate the activity to the human task component, and this is the one which performs and manages and executes all the human interaction within the process engine. So whenever a user task is reached in the process engine very duly delegates a task to the human task component, and it makes the interaction between the user possible. So the different components that are involved in this human interaction are: we have a task UI. That's the UI which the end user or the human actor is going to interact with the data. So data is going to be shown in the UI, and user input is going to be captured in the screen and brought back to the human task component. And all the authorization and authentication is going to happen using the user group component, and this component is going to take its input from the organization central repository, the user repository. So the data flows from the user repository to the user group. So when a user comes in, it's going to check whether this user falls within this user group, and the task that is configured is also for the same user group. If those two matches, then the task will be made available to the user, and the UI will be presented to him for him to interact with the data and give his inputs and then submit that. And again, the human task gets the input, does all its job. Once the task is completed, it again gives back the control to the process engine for it to go forward and execute the other tasks that are configured in the process. And this runtime DB, this is used for actually storing transaction data, the runtime data, and that is again standards-based interaction. It uses JPA connectivity to store and retrieve the data in the runtime database. So this is the whole high-level diagram of how a human interaction occurs within a process engine. You'll see what I've written here. Human task component is a very lightweight component. Again, it's a Java component and it's very lightweight. And this human task component, again here the industry-wide practice comes into picture. They have used this WSHT standard, Web Service Human Task Standard, that's developed by the Oasis group. Herein they have captured all the industry-wide practices for handling any workflow kind of activity, and that is being implemented by this human task component within Jbpm 6. So they have got all the normal scenarios which can happen within the when a workflow happens, and the whole life cycle is captured within this human task component. So it also implements this standard. Yeah, this is the component which makes human interaction possible, manages the whole life cycle. So this is out of the box AI workbench way of handling the human interaction. So the other way to handle the human interaction is by by considering this whole process engine as a service, and we having our own external application which consumes this external process engine, and the human actor doesn't even know that there is a process engine at the back. He just connects with the external application and gets the whole thing going. So that's what. So the interaction between the external application and the process engine is made possible using the API that they have provided us. So there are three different ways of communicating to it. The REST API that they have, the REST web services that they have provided REST URLs to connect to. Directly we can invoke those REST URLs and connect to it. They have given the JMS interface as well, and also a remote Java client on top of these two REST and JMS interfaces. The remote Java client makes use of the KIE API objects like KIE session, task service. These are the objects which the same objects interface is used to interact with the REST service internally and connect to the process engine. What advantage it provides us? It provides us like we don't have to deal with the intricacies of how the data is flowing from our application to the RESTful web service or anything like that. We don't have to do the serialization, all that. We will just be invoking the remote API objects just like we will do within like a normal Java object. But that object is capable of handling all the data connection between the process engine and the external application, how to send the data to and fro, all that is being handled behind the scenes, which REST service to invoke, all that is being handled by the remote Java client API that they have provided us. That's one superb feature that they have given us. For this particular interaction to happen, the API that we are using is the task service. So I've just given this is the interface org.kie.api.task service, and some of the methods that we see: claim, start. These are the buttons that we will be seeing when the human actor is interacting in the workbench. Delegate, fail, skip, forward, complete, get all the tasks for a particular user. The one that we see on the UI with different rows, 5 tasks pending for a user, that is obtained using this particular method, and many such things. And this is a sample project that we will be creating. First we will be looking at the sample process, and then we will be creating the same. This is one of the quick start project that comes out of the box. It's already in a running condition. Once we will take a look at it, and then we will create the whole thing from the scratch and understand how each component works and how to configure each one and actually implement it from the scratch. It has got this one human task involved. So basically what it does is there is some claim amount or some amount that will be entered into the system, and based upon whether it is greater than 10,000 or less than 10,000, the approval process is going to change. If it's greater than 10,000, it needs a human approval. A guy has to go and approve it or reject it. He can even reject it. So that thing he can do. If it is less than 10,000, it is always getting approved. It's approved by the system, and then it goes here and it directly goes to the approved stage. But when it goes to the user, he can either approve it or reject it. The thing can take any one path. So that's what we are going to see now. So this one I will show you how to do it. Okay. Now we'll see how to create this business process. So we go to the authoring menu, project authoring. Project authoring, and then you say new item, project. We'll create a new project for this thing. So let's say use training. We'll create a new project called training. Okay. We'll give some description to it. and click finish. Okay, it is got created. Yeah, a new project called training is created. We'll close all the other stuff. Okay, now we will create the business process. First we will create the business process. Now we'll go and create a new business process. We will save it so that the edit gets saved. New business process, sample approval process. Okay. So we have got the business process created here. Sample approval process. Okay, we've got the start node. We'll create the variable definitions. We will click on this drop down button, click add variable, type amount, and give the type as float, and click on add variable again, give a float, and select boolean. Okay, click OK. Now we have defined the process variables. Let's define the training.sample as a package, and then we'll go ahead and create the remainder of the process. So click on this thing, you'll get this contextual menu. Click on the activity. So this is the first activity. As I said, this activity is just going to display the input that was received by the process. So we will just need a script task for this. We are not doing any business logic here. We're just going to print the data that came here. Yeah, so we have defined it as script. So as soon as I select the script, these are the properties which comes from an abstract task. So when I select it to script, it will show the properties only that are specific to the script task. So for the script task, only 3 properties are specific. So it has a name. Name is the one which gets displayed in the visual diagram. So we will say amount display. Display amount, we will say display amount. So that became the name, and the script, the code that needs to be executed. We will write system.out.println. We want to print the amount, right? The amount received by the process. The amount received by the process is, since the process variables, as I said earlier, it's available throughout the whole process. So I'm just giving the amount variable here, amount. Click OK. Okay, so we have printed the amount that came to it. And these are the on entry actions, on exit actions. If we want to write something, we can do it. So we have defined the first task for us. The next thing is we need to determine if the amount is greater or lesser than to 10,000 rupees. So that's what we need to determine. So we will go for the gateway. We will go for the gateways. So what gateways we need to go? Since only one execution path is going to flow after the condition, we should go for the exclusive OR gateway. We need to after a condition check, we need to enable only one particular path. So we will be using the exclusive OR gateway. Either we can take it from here, drag and drop it just like this, or even we can, this is also the same thing that is coming from the contextual menu. We could have selected it from here, okay, but we just took it from the palette, the object library. Now we will use this to connect this and this. Just click this arrow mark and drag it to here, it will get connected. And now we need to define the to execution thing. So if it is less than 10,000, we will have an activity. That activity will say the amount is auto approved by the system. If it is greater than 10,000, then a human interaction is required. For that we will create a human task. So this is a script task and this is a human task. We'll first define the script task. What we will say, we will do the same thing. We will select the task type first, script, and then click on anywhere. It will show only the properties of the script. So say the name is approved. Let's just print system.out.println the amount is approved. Okay, the amount is approved and click OK. Now we have configured this one. So this becomes a user task. Click on it. Select the task type as user. I'll just check with them. Select the task type as user. An icon will appear here, a human icon, and go and give the task name for it. So the task name can be approval, amount approval, let's say. And this name is the one which is going to appear on the, this is the display name which is going to appear on the diagram there. So let's say amount approval again. Okay, and now we need to configure the group who will be acting on it. Let's say an analyst is capable of taking this decision, so we are configuring analyst. Whoever is assigned the analyst role will be able to see the task in this queue and take appropriate action for it. And we have these are the ones which we were talking about: data input set, data output set, and the assignments. So the amount is entered at the starting of this process, and that is captured in the amount process variable. So when that amount needs to be this task needs to have access to that amount. How do we do it? So we will create an input variable first. That's the data input set. Data input set is the input properties for a particular task and for the user task. So we will say amount underscore in. Okay, so that it is this in underscore in is to differentiate that it is a task variable and not a process variable. And we will say same float. This is the only input that we need. The approval property of the process is going to be the output from this particular user task. Based upon the amount that the user sees, he is going to take a decision whether he is going to approve it or not, and that will be captured in the output variable, and the input, this will suffice. Amount underscore in should suffice now. And we will create data output. Add data output. We will say approved underscore output. So this is the output variable from this task. When the user says approved or not approved, this is the variable that will hold the value, and this is the variable that will send the value back to the process variable approved. We will select it as boolean and then click OK. And now it's the assignment time. We need to map the input variable and the output variable of the task to the process. That will be done using the assignment. So first is new data assignment. So this is data input assignment. So we need to assign the input data first. What is the input data? The input data is the amount underscore n. So we will select the variable from which this amount underscore in is going to get. So this variable definition amount is the process variable. So we select the amount process variable. From the amount process variable, we are mapping it to the process variable amount is mapped to the task variable amount underscore n. By this way, whatever data that I got from the process, I have mapped it to the task using this assignment property. Now the output, the approved value is going to come from the task. So I need to send that value from the task back to the process. So how do I do that? I create a new data output assignment and then select the task variable here. This is a task variable, approved underscore out, and I'll say this task variable is mapped to the process variable approved. So this is how I'm mapping. So I have created an input assignment, I have created an output assignment, and this is how the data flows from a process into the task and out of the task again back to the process. So be very clear, when it goes output, the process variable's value gets affected. While it comes in, only the task variable gets affected. And the scope of the task variable is within that scope only. The scope of the process variable encompasses the whole process itself.